Hi guys, in this video, I want to solve this Leetcode 198 house robber. So imagine that we are a professional robber planning to rob the house along a street, and each house has a certain amount of money um, stashed. The only constraint stopping you from robbing each of the items, each of them is the adjacent house have a security system connected, and it will automatically contact the police if two adjacent houses were broken in on the same night. And so we're giving an array of nums representing the amount of money of each house, and return the maximum amount of money we can rob tonight without alerting the police. So let's look at this example. And so for this particular case, the first house has 1 unit for $1. Second house is $2. Third house is $3, and fourth house is $1. So one approach would be, because we cannot rob two adjacent houses, so we can rob the first one, and the second one is adjacent to the first one, and then we can go to the third one, and that's one solution. Secondly would be we can rob this guy and then rob this guy, the second solution, or we can rob this guy and the last one. So there are three ways to do it, and then we come after comparing all the ways. This way, the way that we just rob the first one and then the third one, and that will be the giving us the highest amount of money. And second example, we can rob this guy, or rob this, and then rob this guy and rob this guy, or we can rob this guy and then rob this guy, or we can rob this guy and then rob this guy, or we can rob this guy and rob this guy. Right, so that's that many cases, and among all the cases, if we rob house number 1 and then house number 3 and house number 5, and that will give us the highest amount of money. So there are many ways to solve this problem, and one immediate way will be dynamic programming. So we can have a recursor. Basically, we will recursively calling this function, and so the way that to do dynamic programming is, first we have some termination condition. So we have the starting point within this nums list, and meaning that if we starting from this house, and what would the solution would be, and then we recursively moving forward in the nums in the nums. So there are two termination cases. So the starting point, if we are starting at the last house, and the total amount of money, and we started at the last house and ending also at the last house, and the amount of money will be just that last house. So that's the trivial case. And then if we are standing beyond this list, we are standing over here, and that means, and then we ending on this house, that means we cannot return anything. That's why we return 0. So there are two edge case that we can terminate this recursion function, and the recursion comes from here. So it's a maximum of the amount from the current house plus the house that is not adjacent to us. So if we rob this guy, so we are collecting that amount, and then we jump to this house. So the starting point will be here. So the starting point will be here, could either be robbing this house and then onward, or we're robbing this house and then onward, right? So there are two cases. So this is the recursor, and or if we are sending this point, we can just not robbing this house, you can rob the next house, and so the starting point will be here. Not necessarily robbing, we can start from here to think about the problem. So and then because we're standing at the beginning, that's why the recursion comes from 0. So a little example in here show you how exactly this works. And we have a rec, IEC rec is the basically is recursor, just a shorthand. rec0 is equal to maximum number at the 0. Basically, this statement over here, because we are not touching these boundary cases, plus rec2. So because 0 plus 2 equals 2, and then the maximum of that and the rec1, 0 plus 1 is 1. And then this number is just the first number, this is 1. And then now we're asking ourselves what's rec2 and rec3, rec2 and rec1. Basically, it means that we are looking at a problem, thinking that we are in the second position, so we are in here. And rec1 is we are standing here, and think about the problem over when we are standing here. So rec1 is the maximum of the num1 plus rec3, and the rec2, we just have simply applied that formula. And rec2 over here is equal to the maximum of the num2 plus rec4, because 2 plus 2 is 4, and then rec3, because 2 plus 1 is 3. And then we are asking ourselves, what are these two numbers, like rec1 and rec2, what are they? And then to solve those, the first one is the rec1 equals the max number of 1 is basically this number over here, and rec3 is actually 1, because rec3 is the third, is the index 3, so 0, 1, 2, 3 is we are at the boundary in here. So it's equal to the number of numbers, the length of numbers minus 1. In this case, the length of number 4 minus 1 is 3. So we are in the boundary. Just basically we are returning that number. In this case, is 1. So we have this number filled out. And now is what's rec2. So rec2 is equal to the maximum of num2. As you can see, so we are basically duplicating the work, right? So we are asking, when we are asking ourselves what's rec1, so we have to do rec2. And when we are asking ourselves what's rec0, and then we have to compute rec2 as well. So as you can see, the work is duplicating. That's why this solution is not efficient. But anyway, let's follow it through. And the rec2 equals the the numbers and the position 2 plus rec4. And then the maximum of that compares to the rec3. And rec4 is actually for outside the boundary, so that's why rec4 is 0. And then rec3 is actually 1 that we just talked about. And what's num2? Num2 is 0, 1, 2. Actually, this number is 3, right? So this is exactly how we solve the rec2 now. And rec2 is after we do the arithmetic, and it's sorry, I couldn't talk. And that's 3. Okay, so we have this number over here. We have this number over here, but when the recursion is executing, basically this computation is being done twice. That's why it's not very efficient again. And then rec1, now we know nums at 1, basically that's 2 plus rec3, we computed already. But as you can see, this statement is being repeated again, so this is not efficient. And then compared to the rec2 is 3. So after we put the number in, compare the maximum number is 3. And then we can go all the way after plugging all the number to this formula here. We have all the number in here already. So it's 4. That's exactly this answer. So this method works, but because it's not very efficient, we have already a lot of repetitive steps. That's why this is not accepted by Leetcode. And we can improve on that by using dynamic programming, because as you can see, a lot of intermediate steps are repetitive. So we can save those intermediate steps, because this number is not going to be changed, right? When we come back to those questions. So we can use a memo array to save all the intermediate steps result. Yeah, I'm going to show you how can we implement that. But this recursive way is really good to build up an intuition where we can And then after that, we can use the intuition to build up the dynamic programming approach. So yeah, I will show you how can we do that. And now let's solve this by using dynamic programming. And so we first did a edge case. For this function, we need an edge case where if there's only one house, this is trivial. Just return the money in that house. And then we need a memo dictionary, because when we look up in the dictionary, it's a constant lookup time is a big old one. That's why it's very fast. We use that to store all the intermediate steps. So the key would be the starting point, and the value would be the amount of money for a sub-problem that we are looking from that point, as we saw before. So basically, the memo dict is to store all the intermediate steps result. And we can initialize the dictionary by using the keyword none everywhere to be the values. And for the recursor, which was very similar to what we had before. However, some modification will be so first will be some edge. I mean, these are the two edge cases we saw before. If we are at the last house, or if we go off the nums, all the available numbers. So these two edge cases we talked about, and we added this. So if the dictionary, the value is not none, and then we can just read directly from the dictionary. And then this is the same as what we talked before. And instead of returning will be the next step. In addition to the returning, we also store it in the dictionary, and also we return at the end. And then we have a trigger at 0, and then trigger the whole thing running. And then because we are standing at points at the index 0 to look at the problem, that's why we return the memo dict at 0. And this runs successfully, as you can see. So in terms of time complexity, I'm going to borrow that from the official solution. This is exactly the same idea as in the official solution, but just different. The name of the variable is different. So the time complexity is big O of n because the process we process at most n recursive calls, and because and due to the coaching, and during each of the calls, we make a big O of 1 computation, which is simply making two other recursive calls and finding the maximum. So this maximum takes a big O of 1 and populating the cache based on that. And also when we look up from the dictionary, that takes a big O of 1 as well, because there's a hash map. So essentially what it says is this time complexity is entirely just from the recursive function. And for spaces, the space complexity is by the recursion stack, and also from the dictionary, the memo dictionary. So it's a big O of n. Okay, so that's so much for this problem. And this question was quite popular. You can see so many commonly asked previously, and I hope you like my solution, and hopefully I can see you in the next video. Thank you for watching.